On the back side of the notes, these just get a little bit more complicated. We just get a few more little tricks that we're going to try out. But number 4, I gave you a little hint. We want to verify by converting everything to sines and cosines. Sometimes that helps, so I want to show you an example of that. So right now I'm just going to work with the left-hand side of the equation. Cosecant is 1 over sine and minus sine. Okay. Now, the right-hand side of the equation is 1 term, and the left-hand side is 2 terms, so I'm probably going to need to combine these things. So these are fractions that I need to combine. So I need to get a common denominator, which is going to be sine. So I need to multiply top and bottom here by sine. So that way I have common denominators. So this is going to give me 1 over sine minus sine squared over sine. And when I combine this into 1, I get 1 minus sine squared. All right, now I've only worked with the left-hand side of the equation. Oh, you probably recognize this. Pythagorean identity, 1 minus sine squared. We can replace that with cosine squared over sine. Okay, I'm kind of at a point that I'm not quite sure what to do with that yet. So I want to show you something that we haven't really talked about yet, is we can work with both sides of the equation, okay? We can't switch anything over. Remember, we're not allowed to cross the equal sign. But I can also manipulate the right side, which is what I'm going to do now. So I'm going to come back to the right side. I have cosine, and I'm going to rewrite cotangent in terms of sines and cosines. So cotangent is cosine over sine, which this is multiplying fraction, so I can just put that over 1. So cosine times cosine is cosine squared over sine. And that's what I have. So I'm just going to go ahead and put that down there. See, that's the same thing. I can rewrite it 3 times, but I'm not going to. Okay, so you are allowed to manipulate both sides of the equation until you get something that's the same on both sides, which is what I did here. All right, something else, another trick that sometimes works is rationalizing the denominator. Okay, so I've given you that hint, so that's what we're going to start with. I'm not going to mess with the left-hand side of this equation right now. Cosecant x plus cotangent x. All right, to rationalize the denominator, I'm going to multiply top and bottom by 1 plus cosine x. 1 plus cosine x. All right, so the numerator, I am not going to distribute that. I'm just going to leave it. So we have sine x, 1 plus cosine x. And the reason for rationalizing, what we're kind of calling it, the denominator, is we're going to have stuff that cancels. So we get 1 plus cosine minus cosine. I'm not going to write those down. They just cancel. Minus cosine squared x. All right. Hopefully you recognize this. That's a Pythagorean identity, or it's a version of it, right? If we have sine squared plus cosine squared equals 1, if you subtract the cosine over, you can replace this with sine squared. So we have sine x, 1 plus cosine x, over sine squared. Right? This side is still cosecant x plus cotangent x. Now one of my sines will cancel. So I have cosecant x plus cotangent x equals 1 plus cosine x over sine x. Now, there's a couple different ways we could go about this. I'm going to keep working with the right-hand side. If you wanted to work with the left-hand side, you certainly could. But notice my left-hand side is 2 terms, and my right-hand side is 1, but I could split that up. I could split that up into 1 over sine x plus cosine x over sine x. Okay, they have a common denominator. I just pulled it back apart. And then I'm still not doing anything to that left-hand side. 1 over sine x, if I use my reciprocal identities, that's cosecant x. And cosine over sine is cotangent. And we have accomplished it. Okay, so rationalizing that denominator made some nice things happen as far as my substitution. So that's another tool that you might find useful.